Okay, this is my assignment to report for rendering. So the first thing was the gradient star. So here's the pixel shader. The vertex now has position and color. And then you just assign each of the values in the vertices in the vertex buffer. And if I run, I get this beautiful thing. And stop that. So that is question 1. Question 2 was similar with, but with no gradient. So all the same setup, except you had to reuse the vertex positions, or sorry, have vertices that had the same positions but different colors associated with them. So you kind of had to rearrange vertices and the indices. But you end up with this guy. Okay, next was the messing with the input layout. So yeah, basically when you try to do the triangle position color, the shader, is it this one or I think it's this one? Yeah, the shader remains the same. You don't change anything about it, but you have to change the input layout because now color is first and then position. So when it looks for the color, when the vertex shader looks for the color label, I forgot what these are called, whatever that is called, it looks at the 0th byte, and then for position it looks at the 16th byte. So that is all you had to change there. Oh, and I gotta run it. Come on. And you get the same thing. Okay. Question 4 was the user-defined star colors. So I did the vertex now contains a color and the position and the color number. You have the constant buffer, the handle to the constant buffer, which is an array of 2 vectors, which are the colors. So we're just assigning each of the different triangles, so like the right triangle, the top, the left, the bottom all have an index 1 color number, and then the middle 2 have the 0. So then when you assign the colors down here, you can just set the, so you enter the center color here, which is the 0 index, and then the point color here, which is the 1 index. So you can change them here, and then in the shader code, you need to define the constant buffer here. This is the shader constant. And then in the pixel shader, you just pass all this information through. And then in the pixel shader, you just say, hey, color array, which is pointed to right here. Whatever this pixel is, do the color number of that. So that's how all that gets communicated. Back to here, so I just had aquamarine and purple. If we run that, we get this guy, but then you could change it to be like red in the middle and blue on the outside. Come on. Here we go. Right. So it seems to be working. Okay, and then in terms of the further work, I have some notes here, and I was going to pull up the PowerPoint. So for the first one, what is the difference between a constant buffer and a shader buffer? Sorry, constant buffer and a shader constant. Here we go. Okay, so basically the constant buffer is a way to send data to the pipeline during runtime and not through the vertex buffer, so it can be changed dynamically. For example, color. It is constant according to the render pipeline, so for that one frame, when you are calling draw indexed all through the entire pipeline, it doesn't change. Change during runtime, like I said, and this is on the GPU, CPU communication side. The shader constant is a way for the shader code to access the constant buffer, so access point, you can control which data buffer it points to, and it's on the shader side of things. So in terms of setting all this up, which is kind of what this slide went over, you have to reserve space for the constant buffer on the GPU, like here, and keep the handle to it. Then you declare you set up the shader constant in the shader code. So you basically declare the constant buffer right here. This is the shader constant. It points to nothing originally, but you give it this a name so that you can use this name throughout the shader code. But then you have to actually connect this buffer space that you reserved and tell the pixel shader, hey, look here when I want to access this buffer, when I want to use this data. So you have to call this the set constant buffer, and that kind of creates this connection so that the shader code can access that constant buffer during runtime. So that's kind of the differences between them and their uses. For further work 2, I'm just going to go way back up here to explain the rendering pipeline. So this was where we had the triangle, and you wanted like the vignette around the sides, but you ended up getting it in the middle. And basically why that happens is that when you call draw scene, the back buffer is cleared and you just fill it with the background color. So that's this dark blue. So the whole background is dark blue. And then you are building the next frame in the back buffer. So you call draw indexed and trigger the rendering pipeline. But the rendering pipeline is called once per model per frame. So it's just called on the triangle. What happens is that the input assembler collects all the vertices and knows how they're connected to send it to the rest of the pipeline. The vertex shader is called on each of the vertices, so 1, 2, 3. It's just passing the info through right now. The rasterizer combines the vertex information and computes the pixels for each triangle. So it says, hey, here are these 3 vertices. I'm going to pump out all of these bajillion pixels where this triangle is covering the screen. And then for each face, for each pixel of the face, so for every single pixel along here, that's where we finally reach the pixel shader. So it goes, hey, right here, what color does this need to be? And that's where this like white shade code is running. So it's running only inside the triangle and all of these pixels. Right, so it's saying for every single pixel in here, what kind of shade of white does it need to be? And then after that, it combines everything and sends it to the render target. So long story short, everything that goes through the render pipeline has to be a model, with vertices and stuff. So you can't change the background. Like none of these pixels are ever going to reach the pixel shader because they don't go through every other step of the pipeline, which is called just on the model and on the faces of the model. So yes, that is why that does not happen. Okay, I'm going to shut up now. I think I covered everything.